Okay, so moving on, let's talk about quasi-experiments, and then we'll talk about extraneous variables and context. So with quasi-experiments, it's going to look, this is something where you um, compare two or more groups. However, it's not based on something manipulated, it's based on a pre-existing condition or trait or factor, okay? So it looks just like an experiment, but it's different. Um, this would be anything like, say, comparing older versus younger adults, men versus women, um, you know, one language versus another, anything like that. Okay? Anything where you're not manipulating something, but rather you're relying on an existing fact. Now, quasi-experimental variable is of course going to be a correlational variable because it's not manipulated and because it's not randomly assigned, which we'll get to next. It looks now just the reason I don't want you to get confused here is that it looks just like an experiment. It looks just like an independent variable, but it's not. It looks similar because with a quasi experiment, you're going to have multiple conditions or two or more conditions at least, and you're going to compare them and make a hypothesis just like you would with an experiment. But all the shortcomings or limitations of correlation still apply here because it's not something you're manipulating, it's something you're um, dealing with that's already existing. So we can, and of course, what's the big thing with correlations? Well, we can't say that there's causation. So just like with correlations, though again, it looks like an experiment, we can infer causation. So I kind of mentioned age being an example. So maybe I look at, do older versus younger adults show better memory. Another example would be um, if you're looking at, say, the bystander effect, or who's more likely to help someone who looks like they're injured, males versus females. Um, you know, I might make the hypothesis that women will help sooner than men. So the dependent variable is time to help. The quasi-independent variable is gender. Um, Again, this looks like an experiment, and the hypothesis is just like an experiment, making a prediction about this group is going to do, score higher or lower on this dependent variable than this group, but it's still non because it can't be randomly assigned unless we can't say caused a difference in the dependent variable. Okay, so a couple of key features with regard to experiments that we've kind of touched on already is, of course, manipulating an independent variable, as well as there being extraneous variables, but also there being random assignment. So whenever you do a study, whenever you do, or rather an experiment, it's very essential that you randomly assign conditions. So you can do this any number of ways. You could flip a coin. You could split them up by just like numbering them off. You could use a random number generator, something like that. Key is that it has to be random. You can't, you know, put people into conditions or groups based on something that isn't, because that can mess with extraneous variables, our next issue. So what exactly is an extraneous variable? Well, this is anything that could cause differences in your dependent variable, but it's not something you're intending to. So to give you some examples, an extraneous variable would be, again, anything that can cause differences in your dependent variable that's not a part of your manipulation. So let's say I was running a comparison of talking on a cell phone versus no cell phone and driving, and I ran an experiment on it. Well, um, extraneous variable would be baseline driving skill. So regardless of the manipulation of some people having cell phones and some not, some people are just going to be better drivers or worse drivers, regardless of the manipulation. Right that would be an extraneous variable, and that could, contribute to differences in scores or a number of mistakes made. But again, it's not due to manipulation. Another example would be, let's say we were looking at a memory test. So I wanted to know what's a good way to study. Is it rereading your notes, or I don't know, taking a practice exam? Well, an extraneous variable would be, say, how hard people study or how much attention they pay in during the studying. Well, those would be extraneous variables because it's stuff that could affect the dependent variable. Obviously, if someone's paying more attention, they're going to probably do better, but it's not part of our manipulation. Now, a very important thing to always remember with regard to extraneous variables is that they may or may not be problematic depending on a couple of factors. So sometimes with extraneous variables, you can hold them constant and you can measure them. So, and we won't really go into that because that's kind of another topic, using what's called covariates and stuff like that. But the big thing when it comes to um, canceling out extraneous variables is going to be random assignment that we talked about a few minutes ago. So remember, when people come into your study, you have to randomly assign them to conditions. And this accomplishes something very important. It accomplishes making extraneous variables equal or almost equal across conditions. Okay, we'll come back to this. So let's say that I have people come in to do my memory study, and the people in one condition, or sorry, I know obviously that some people are going to pay more attention than others, right? Some people are going to try harder than others. Well, this could impact my dependent variable, because obviously trying harder could result in better memory. But a key assumption behind all experimental design is that it's going to even out because you're randomly assigning people. So because I'm randomly assigning people, I'm going to get an equal number, almost equal number of people who pay attention in the one condition and people who pay attention in the other condition. And then I'm also going to get people who don't pay much attention, equal number in both conditions because I'm randomly assigning people. Okay, so it should about even out with a decent size sample. In the other example of cell phones and driving, yes, some people will be better drivers than others, make more or less mistakes, but again, that should even out because I'm going to randomly assign people. So that's a key thing. Random assignment evens out extraneous variables. By the way, extraneous variables will not be 100% even across conditions, but that's why we run statistical tests, which we'll get to later. So for now, just kind of assume random assignment evens out extraneous variables. And by the way, that kind of gets back to our key assumption. Because extraneous variables are going to be equal across conditions, we now meet our important criteria of ruling out alternative explanations. We know that any change in the dependent variable has to be due to our manipulation, because everything else, including extraneous variables, is now equal across conditions because we randomly assign. Okay. Now, there are situations where an extraneous variable is not random, and that's when stuff goes downhill. So when an extraneous variable is somehow systematic or isn't randomly distributed across groups, you're going to end up with something known as a confound. Okay. So a confound is any extraneous variable that isn't equal across conditions or also covaries, correlates with your independent variable. Okay. Let that definition sink in for a second. So an extraneous variable is or a confound is an extraneous variable that covaries with your independent variable. And then we're going to go through some examples in just a second. But anytime you have some extraneous variable and it's not randomly distributed across conditions, then it becomes a confound, and then it's very problematic. So just to give you one example, or several examples here, let's say I wanted to look at emotion and memory. So I give people either emotional words to study or neutral words to study. Remember, the key there is that things should be equal across conditions, right? Well, that applies to the words themselves. Now, some words might be more easy to remember than others, independent of the manipulation of them being emotional. But the question is that going to be equal across conditions? Well, it might be or it might not be. Let's say the emotional words tended to be longer. Well, that could be a problem, right? Because now they're more memorable because they're longer, or even less memorable because they're longer, not because they're being emotional. That would be an example of a confound. So something is that could affect the dependent variable besides your independent variable, but it's not equal across conditions. It's going to covary, it's going to change along with your independent variable. So I might claim that I'm manipulating the emotionality of the words, but I'm actually manipulating some other factor, say how frequent of a word it is or how long it is, just as an example. Okay. And this is obviously very problematic because now we don't know, well, is it because of your manipulation that you claimed? Is it because of word emotion, or is it because of that thing that also varied along with emotion? Okay. Let me say that one more time. So with a confound, because it's not equal across conditions, because it covaries with your independent variable, it varies along with your independent variable. Now we don't know what the cause is. Is it the thing you said you manipulated, words being emotional, or is it the thing that varied with that factor of the words being less frequent or say longer? Okay. And again, this contrasts with just a regular extraneous variable that should be equal across conditions. So the emotional words are, some are more easy to remember than others. That's somehow equal across emotional and non-emotional words, then that's okay. Okay, let's look at a couple more examples before we wrap up this issue. So think about this and whether it's an extraneous variable or a confound. So is it equal across conditions, or is it varying with the independent? Two researchers investigate whether face-to-face or phone questions produce better answers. Don't worry too much about the specifics here, it's just an example. One researcher does the phone interviews and one does face-to-face. Think about it for a second. So hypothetically, different people, different researchers asking the questions could influence the results here, right? Because I mean, it's not maybe super probable, but it's certainly plausible that maybe they phrase them slightly differently, maybe they're more welcoming or patient or whatever it might be. But different person asking the questions is could definitely influence the dependent variable, right? But ask yourself, is that equal across conditions or not? Well, it's not here because one researcher is doing the phone to phone interviews or phone interviews and one does the face to face. So the confound of who's asking, or the extraneous variable of who's asking the question, is varying along with the actual variable of phone versus face to face. Again, this extraneous variable is not equal across conditions. It hasn't been randomly distributed. Okay. In contrast, let's say that the two researchers split it, and one did half the phone interviews, or rather, Yeah, one did half the phone interviews and half the in-person interviews, and the other researcher did half the in-person. Well, then it would just be an extraneous variable, not a, because although the person asking the questions could influence the dependent variable, it's now equal across the conditions. We now know that the any effect that that might have is going to be equal across conditions, because um, both researchers are doing both conditions equally often. Okay, another one. A researcher wants to know if taking a caffeine pill before running makes you faster. Some people respond more to caffeine. So let's say here I would give one group a caffeine pill and one group a placebo, so just like an empty pill. Um, is this a confound or extraneous variable? Well, this would be an extraneous variable and not a confound. Because ask yourself, is people being more responsive to caffeine equal across conditions? Should be, right? If we randomly assign people, we're going to get um, those receptive to caffeine and those less receptive about equal across conditions if we randomly assign. So this is not a. By the way, that is something you could hypothetically control for. You could ask people how much caffeine they typically consume and are they susceptible to it, possibly. Okay, next. The researcher wants to know if studying with the lights on dimly improves memory. Some people see better in the dark than others. Is a confound or extraneous variable? Well, this would be an extraneous variable. Because again, ask yourself, if people are, yes, some people might be able to see better in the dark, or however, whatever that is, but it again should be equal across conditions. Those people who are better at seeing in the dark should be equal across condition. Better or worse should be equal across conditions because we're random assigning. It's not the case that say some people are. It's not the case that it's varying along. Okay, last one. Researcher wants to know if studying while standing is better than studying while sitting. He runs this on a class, splits people up by front seats versus back seats. So he takes the first half of the class closer to them, and they do the standing condition, let's say, and then the back of the class does the sitting condition. Is this a confound? This would be a confound because it's not. Now we have something that is covariant along with the independent variable. We haven't randomly assigned people, but we know that sitting in the front of the class is now covariant with them either standing or sitting. So now we can't disentangle, is it the standing or sitting, or is it the case that people who sit in the front of the class um, have better memory than those that sit in the back? Probably not true. It's certainly possible. So again, you're manipulating something extra with what you're already with. Thus, we have the problem. And that's kind of the golden rule of experimental design. Again, everything should be equal across conditions, except for that one single thing. Okay? And just building off that rule, that kind of closing thought there, when we use a correlational or quasi-experiment, is everything constant across conditions? Do we know that if we compared, say, looked at GPA and time studied, do we know that everything is equal except for the study across condition or across levels? Well, no, right? Because it's correlational. We don't know what else might be also co-varying along with the amount of time you spend studying. Same with a quasi experiment, right? If we compared, say, younger versus older people on memory, some sort of memory test, well, we don't know, is it age or is it something that co-varies with age? We don't know because we didn't manipulate it. We don't know if everything is the same except for age, except for that one factor we're identifying. It's only the case when you manipulate. Okay, stop there for now.